Okay, several of you have asked me to go over the different types of right-hand rules we've covered in the class when we're talking about electricity and magnetism. So here's a quick video to try to describe those things. So first of all, there's two types of right-hand rules. I'll verbally describe them here, and then I'll graphically go over them in the next few slides. So the first right-hand rule that I want to talk about here relates the direction of current flow, which will be in the direction of your thumb, to the direction of the B field, which will be given by your curled fingers. Okay, so that's current flow and B field. The second right-hand rule relates three things: the direction of a moving charge or current, that's your arm and outstretched fingers, to the force, which is your thumb, and then the direction of the B field, which is your bent fingers. So I'll just try to show these things here. So let's go over rule number one first. Okay, this is rule number one. It relates the direction of current flow, which is given by this blue line. So here we have a wire going vertical. It's got current going from the bottom up to the top. And if you grab this with your right hand and point your thumb in the direction of current flow, then your fingers will curl around the direction of the B field. And so when viewed from above, this would look counterclockwise. So that's how you get the direction of the B field. So this is for a straight wire, but you can also do it for a loop. So say I've got a loop here, and the loop's got current basically going counterclockwise, like that. You point your thumb in the direction of current flow, roughly like that, and you grip your fingers around the wire. And if you do that, what you'll see is these types of things happening. So your fingers are going into the board or into the paper on the outside of the hoop, and that's represented by this. Everywhere around you see these little X's, which is the tail fins of the current arrow, or sorry, the B field arrow, as it's going into the board. Now, if your fingers were to curl all the way around the hoop, they would come up in the inside of the hoop. And that's given by this little dot saying that the B field is going to come up in the inside of the loop. So when you have a current loop, what will happen is the B field direction will be partitioned in different directions inside the loop and outside the loop. And in this case, the B field is coming out of the page inside the loop, and it's all going down into the page outside the loop. Now here's the other right-hand rule. The other right-hand rule relates a moving charge in a B field, and it's going to give you the force. So you take your right hand and you point your fingers extended in the direction of the arm, in the direction of a charge moving. So here I'm just going to do it in the simplest case. We've got a positive charge moving that way to the left. And from this description, we've got a B field that's pointing down into this sheet of paper. Okay? So we want to figure out what the force is acting on this positively charged particle. So we point our fingers like that, and then what we do is we bend our fingers. So it's given down here in the second step. So if I bend my fingers down, they should be pointing in the direction of the B field. And as we see here, the B field is going into the page with these little X's. And so that's going to match this. And the X that you see is just like looking at the fins of the arrow as it's going away from you. So we say this part here, the first part where you extend your hand, that's QV. That's the charge times the velocity. Or it could also be current going in that direction, because a charge moving with a velocity is the same thing as a current. QV, and then we go cross B. I bend my fingers. I take these fingers that were initially extended, and I bend them down in the direction of the B field. And then the thumb is going to give us a direction here of the force. So if we do that, QV, cross B, we get a force that's kind of coming out like that in the direction of the thumb. Now we can apply that. So there's the force. We can now apply that to this particle in the field. So that's the force going to in that particular direction. And what that's going to do is act on this particle and basically cause it to move in the direction of the force. And so it's going to curve around like that. So those are the two types of right-hand rules. QV cross B is the one we just covered. And the one before that is just I is the direction of your thumb, and curling your fingers around gives you the direction of B. Hope that was helpful.